Today we're going to do the hovercraft lab. Now hovercrafts work whether they're the tiny little one like this or if they're a full-size one that people can ride on and cars can go on and stuff like that by basically having a flow of air. So there's a fan inside of this hovercraft, it pulls air in from the top, it squirts it out from the bottom, and then there's this plastic little lip around it, so it basically creates an area of high pressure on the bottom of the hovercraft. In fact, sometimes if you look really closely, you can actually see it underneath. See that little gap down there that's kind of moving around? That's the cushion of air that the hovercraft is riding on. So with just the tiniest little tap, well, the hovercraft kind of bounces around and has a good time, creating just a tiny bit of friction. Really, the friction is called fluid friction. It's a type of air. It's the air that's underneath of it that's getting trapped under there. So there's very little of the hovercraft bumping on the sides, and that's why it travels so smoothly. So let's do our hovercraft lab, or our fluid friction lab, and see how well the hovercraft does. One of the first tests in the hovercraft lab is to see how well the hovercraft slides well turned off. So if I set it up to, I've got my meter stick right here, and we try to slide it, well, it doesn't go very far. In fact, I would say on average, it seems like it's going about 10 centimeters every time I trying to give it about the same amount of energy or same newtons of force in each tap. It's about 10 centimeters that it travels. Right? So it doesn't go very far at all with the hovercraft turned off. With the hovercraft turned on, well, let's see how far it goes with about the same hardness of a tap. Well, it's about 100 meters, about 100 centimeters right there. Let's try again. Well, now that one was about 150 centimeters. Well, that wasn't a very good tap. That's about 90 centimeters. It's about 200 centimeters. One more good one. And that one was about 185 centimeters, I'd say. So you can see when it's just a hovercraft and you're collecting data with how hard you hit it and how far it slides, it varies greatly, right? Because I can't get my finger to be the exact same amount of force every time that I'm hitting it. And so even the tiniest little changes make a great deal of difference because there's so little friction with fluid friction. So unlike rolling friction or sliding friction or some of the other frictions that we're talking about this chapter, fluid friction has by far the least amount of friction to it. So you can see why, if you're somebody and you make a product, you might want to ship it using fluid friction. You might want to ship it on a boat or an airplane because there's so little friction, you can get it there fairly easily. All right, one thing we could do is we could see, okay, if this was a hovercraft, imagine you were transporting your product someplace with it. I wonder how much mass we could put on top of the hovercraft and still get things transported and everything. Now, granted, this is just a tiny little model and everything. Imagine if you scaled this up to like big people version, say like the size of a small building or something like that. Well, what we're going to do is we'll put pennies, right, that I have on here, and we'll kind of tape them on the top of the hovercraft like this. But you can imagine if you scaled it up, each penny might be like an entire ton of material that you're doing. Now when you're doing this, you have to be careful not to block the intake, the air intake. Even though it's a nice little hole right here, it would be easy to I'll put my pennies in there and it's at the center of it. But if you do that, then it's certainly not going to get any air and won't go up. So we're going to assume that our little mini hovercraft right here, let's see how well it does if I put a couple pennies on it. All right, so I'll put, let's say 5 pennies. We'll try 5 pennies. I've got them kind of equally dispersed around on here and everything. We'll see, does it still float? Well, yeah, it floats really good and everything. So let's try 5, 6, 7. Let's try 8 pennies. If I do 8 pennies, does it still hover? Oh, it's hovering. Yep. Oh, no. Yeah, in fact, if I do the same test. All right, so far, it's still, with 8 pennies, it's still hovering just as well as it did before. So let's try 9, let's try 10 pennies. All right, we've got 10 pennies on there. We're getting a little bit weighty. 10 pennies, it's still going. Let's try 12 pennies. With 12 pennies. With 12 pennies, I think with 12 pennies, I can finally tell just the tiniest bit of a difference on one side. It seems like it's slowing down a little bit. We do the exact same test as before. All right, so for this test right here, 12 definitely seems to be the point where all of a sudden there's just a little bit less, there's a little more friction. It's actually getting some sliding friction going in on that outer ridge right there. So let's say if we do 11 pennies, we'll take one off here, and let's do that test again and see how far it travels with just the 11 pennies. So if I turn it on, and give it a little bop, well, that was about 95 centimeters, right? If I do it again, well, that was almost exactly the same results, about 95 centimeters. Now, that one went about 150 centimeters, but I could tell, honestly, I tapped it a little bit harder than the other times. That was a little bit easier, a little bit gentler. Yeah, there we go, 95 centimeters. So I would say, with our 10 pennies or 11 pennies that are on here, yeah, it's definitely shows an impact, right? There's definitely more mass, there's definitely more friction that's being added onto it. But it's a cool way of showing the difference between the frictions, right? Rolling friction definitely lowers the amount of friction compared to sliding friction, but fluid friction, right, where you're just using air or water, it definitely has less friction. It's a really neat way of talking about, the different types of friction that we have in physics and how you can move things around.